Hello everyone, this is Ms. Figueroa again. We are going to be looking at our lesson 4B-2, solving rational equations algebraically. Specifically, we're going to be focusing on ratios today. So our objective is students will be able to solve rational equations algebraically. You can go ahead and pause the video to write down the objective. For prior knowledge, it's asking us to practice what you learned yesterday to find the LCD. Find the LCD and the excluded values of the equation. So if you remember, in order to do this, you need to factor out your denominators and find what they have in common and what's left over. So in my first denominator, well, first of all, let me just copy the x minus 9. In the first denominator, I have my 2x plus 6, so I can see they have a GCF of 2. So let's factor out the 2. And then we end up with x plus 3. And then my second fraction plus x over 2, I can't really do anything to that denominator. And x plus 4 over x minus 3, there's no GCF. I can't do anything there either. Then I want to check for the LCD. In order to find the LCD, you're looking for what they have in common and what they have left over. So I see they have a 2 in common, so I'm going to write the 2. X plus 3 and x minus 3 are different, so you need to write them separately. X plus 3, x minus 3. And that would be our LCD because I have the shared 2 and the x plus 3 and x minus 3 left over. In order to find the excluded values, remember you're looking for when would this be 0 in the denominator. So remember you're doing like the opposite sign. Anytime you have an x, like 2, remember 2 will never equal 0, so you won't have excluded value there. X plus 3 equals 0. You subtract 3 from each side. Negative 3 would be an excluded value. And if I do x minus 3 equals 0, add 3 to each side, my x would equal 3 would also be an excluded value because negative 3 and 3 would make my denominators equal to 0. So that was yesterday's lesson. We are going to need that for today's lesson. Also, for prior knowledge, it's asking us to solve each equation. So if you remember, in order to solve an equation, it's really asking for us to solve for x. Solve for x. So in order to solve for x, it's a trinomial here, I'm going to need to factor. So if I factor again, a times c is negative 2, my b is negative 1. Those two values would end up being negative 2 and positive 1. So I would have x minus 2, x plus 1 equals 0. And then you need to make each piece equal to 0 in order to solve for x. So x minus 2 equals 0, x plus 1 equals 0. Add 2 to each side, that would give me x equals 2. And then subtract 1 to each side, that would give me x equals negative 1 for my two answers for the first one. For the second one, oops, that's really crooked. For the second one, it's a trinomial again, so you need to factor. A times c is a negative 70, and I need to add up to 3. So I know that 7 times 10 would give me 70, so I'm going to put the 7 and the 10. One of these two needs to be negative because that's negative. If I need a positive 3, I need the 10 to be bigger. So this would be x minus 7, x plus 10 equals 0. Make each piece equal to 0 and solve for x. And so it's really just taking the opposite sign, add 7, that would give me positive 7, and the other one, subtract 10, that would give me x is negative 10 as my answer. So we're going to be solving rational equations today. This is just solving polynomials. So today we're looking at rational equations. Concept, same as yesterday, it's just a review. Don't forget that a rational equation needs to have the variable in at least one denominator. And then rational equations can have extraneous solutions, meaning solutions that are excluded values of the expression in the equation, and in order for that to happen, extraneous solutions create a zero in one or more of the denominators, and extraneous solutions are not included in the final solution set. That's going to come into play in today's lesson. Steps to solve for a rational equation is step 1, find the LCD, which was yesterday's lesson. Step 2 is multiply every single term by the LCD to clear the denominators and use the multiplication property of equality. Step 3 is to solve the resulting equation. Step 4 is check for extraneous solution, meaning any excluded values that make the denominator equal to 0. And then step 5 is to state the final solution set. So let's take a look here. The first example, we have 5 over 6 equals negative 13 over 12x. So if we look back at our steps, step 1 was to find the LCD. So my step 1 is to find the LCD. In order to do that, remember you're trying to factor 6 into 12. 6 goes into 12, so then 12 would be the LCD, and then I also have an x. But 6 times 2 would give me 12. If these two numbers didn't have anything in common, like for example a 3 and a 7, then you would multiply 3 and 7 would be 21 over here. So my step 1 is done, is 12x is my LCD. Step 2 is multiply every term by the LCD. So I need to take my original equation and multiply by the LCD. So let me write that down here. Step 2 is multiply by the LCD. So I'm going to write my fraction. I have 5 over 6, and then I need to multiply by 12x over 1 is equal to negative 13 over 12x, and I need to multiply by the LCD 12x over 1. And I'm writing that over 1 because we're multiplying by fractions. The main thing to do this is for you to clear the denominators. If you look here, it's the whole point of that is to clear the denominators using the multiplication property of equality, meaning whatever you do to one side, you have to do to the other. Step 3 then says solve the resulting equation. So to clear the denominators, I want to check what goes into what. So 6 goes into itself once and into 12 2 times. 12 cancels out with the 12 and the x cancels out with the x. So what do I have left over? I have 5 times 2 over 1, so I'm not going to write that. And then I have negative 13 over 1, so that's all I have left over. So step 3 is then to solve this equation. In order to do that here, I feel like I'm missing an x. Yes, I am here. This is supposed to be 2x. 5 times 2x. Sorry about that. So then 5 times 2x would give me my 10x equals negative 13. And then I need to solve for x. In order to do that, you divide by 10. So therefore, x is equal to negative 13. I forgot to check for my excluded values. That should be added to the steps. But my excluded value is when would this equal 0? The only time that would be 0 is if it's x equals 0. If I plug in 0 times 12 will give me 0. So my excluded value is 0. Negative 1.3, that should be negative 1.3, is not, my 0 is not an excluded value, so therefore this is my solution. Oh, step 4 is to check for extraneous solutions, which I just did, and then state the final solution. Because my excluded value was 0 and this is not 0, then this is my solution. Let's look at the next example. please copy this down. This is 9 over 2x squared is equal to negative 5 over 6x. So, one more time, the first thing you want to do is find the LCD. So you're checking for what they have in common. This is my 2 goes into 6, so I know 6 is the biggest number. And then they have 2 x's in common. This has 1. So I have x and an x squared. They have one of them shared, so this is just going to be 6x squared. If I were to write that in factorized form, like 2 times x over 9 equals negative 5 over 2 times 3 times x. Then here I would look for the shared pieces. So they have a 2 in common, and they have 1 x in common. So it'll be 2 times x, and then they have 1 x left over and a 3 left over. So it'd be x and a 3. So if you multiply all of this together, that would be a 6x squared. That's why the LCD is a 6x squared. Excuse me. So step 2 then is to multiply by the LCD. So you take your fraction, 9 over 2x squared times the LCD of 6x squared over 1 equals negative 5 over 6x times 6x squared over 1, because that's my LCD. And then you want to clear the denominators. So here I can see my x squareds go away, and then my 2 goes into itself once and into 6 3 times. So here I have 9 times 3 left over because the x squared went away. So 9 times 3 equals, and then here my 6 goes away. One of my x's goes away, so this squared goes away. I would just have an x left over here. So then I have negative 5 times x. And then you're supposed to solve. 9 times 3 is 27, I believe, equals negative 5x. And then in order to solve for x, you need to divide by negative 5. And let me grab a calculator for that. I don't know what that is. So 27 divided by negative 5 would be negative 5.4. My x would equal negative 5.4. Then you need to check for excluded values. So my excluded values, you're checking for when would your denominator be 0. Or you can just look at the LCD. The anytime this would be a 0 is if you plug in a 0. So my excluded value is x equals 0. Negative 5.4 does not equal 0, so therefore there is no extraneous solution. So this is the final solution set. That's what you would do for step 5. I'm running out of time for the limit for the video, so I'm going to stop this video now. You're going to have to watch a second video in order to look at the next example that will have a binomial in the denominator. So please make sure you watch the second video in order to finish the notes.